Congrats. So we made it here to the end of the line. So good job, everybody. Just one last homework and exam to go. So the plan for today is really just to get ready for the exam and just talk about what material is going to be on the exam. So I put together a document similar to the one for the last exam. Let me open that up. Which is in Canvas if you want to take a look at it. So the exam is going to focus on the stuff that we've done since the previous exams. That would be functions and cardinality. So the stuff that we covered in chapter 12 and 14. So here's kind of just the typical stuff. The exam's going to be on Zoom again. Same Zoom address, same Zoom link as we've been meeting in our classes. And it's scheduled during our final time, which is on Monday from 2 to 4. Since this is not a comprehensive final, it's going to be as long as your previous exams. So I don't think we'll need the whole time. So the plan is to go from 2 to 3:30. And you're allowed to use all the same stuff as previously and not use the same stuff as previously. And so one thing that I'll just say is I'm giving you guys essentially the same sort of exam as I would if we were in a normal in-person class. And in those situations, I wouldn't tell students that you can bring a stack of notes this high in during the exam, but rather I would say condense your thoughts into one page. And I would encourage you to do the same. So my intention is that you've got like a one-page study guide because it is timed. You don't want to have a huge stack and have to be filing through things to refer to something. So I think it's a good exercise to think about, like, what are things that I can put up here in my head that I don't need a piece of paper for? What are some things that are going to be useful for me to have to refer to on paper, and think about that ahead of time. So you are welcome to use anything that you create. So yeah, that's up to your preference as far as that goes. So yeah, so for example, this sheet I put together, so you wouldn't be able to use this during the exam. But what I suggested for on the previous exams is to go through some of the earlier worksheets and just jot down like what were the main definitions, what were the proof techniques that we did relating to that content. So really the test is going to cover like content from worksheets 20, 21, 22, and 23. Those were the ones that we've done since the previous one. We did talk about functions earlier in the semester, so some of this stuff was on the first exam. But I just kind of grouped together the key definitions and proof techniques for proving things. And so one of the key ideas in this, at least in the first couple of sections, is proving something is a function, proving something is injective, proving something is surjective. So I just summarized the different ways that we can prove something is injective, and we can use all of our different proof techniques. You're probably not going to want to use induction, but you could use any of these proof techniques to prove it. So what that means is this test is on functions, cardinality, and proof techniques. So we can't ignore, I can't say nothing that we've done previously in the previous two exams is going to be on the exam. So you definitely do need to review direct proof. Well, yeah, you definitely need to review this, contrapositive, contradiction in general, not just in this context, as well as induction. So you will see some questions on the exam that are just based on proof technique. So I would just recommend that there were some multiple choice questions that were on proof technique that would be good to review. You might see some of those similar sorts of questions on the multiple choice part of the exam. So in other words, if I wanted to prove this statement by contrapositive, what would be my first step? Those sorts of things. So again, you can take a look at some examples of those sorts of questions on previous reading quizzes or on exam one. There were a number of questions like that. So the main ideas here were proving injective, proving surjective. For the proof technique here, I just wrote how you would do this if you did it directly to prove surjective. And then I just kind of picked a couple of problems. I wasn't planning to do these since we did these in class, but just to pick a couple of good problems that I think illustrate these proof techniques, if you want to practice them, are below. And all of these problems, again, we've done earlier in this semester. So if you do this and you want to check the solutions are in the original worksheet when we covered this. And so I just kind of went through and did this for each of the worksheets. So worksheet 21, composition, inverse functions. Here's a couple of good problems to practice that. This last one is your homework question, which is due tonight. Yeah, and then cardinality of sets were the last two worksheets that we've done. The main idea here is how to prove whether two sets have the same cardinality. And again, the key here is that can we show that there's a bijection between the two sets? And if we want to prove that something is countably infinite, then we're looking for a bijection from N to A. And then here were some kind of key results that we proved, really a number of these in the last class. And so if you do want to review some of the earlier methods, I did add some of this stuff towards the end. So here's direct proof. Here were a couple of kind of typical direct proof things that would be good to review. I did that for contrapositive. Here's how we do things contrapositively. I don't know why there's no step one. Okay, there's step one. Think about the problem and then move on. And a couple of examples of that, and contradiction as well, and induction. So if you do want to spend some time going back and practicing those proof techniques, that would be a good idea to do as well. So in addition to these problems, yeah, you've got the suggested problems that are up in Canvas. So you should expect roughly the same sort of format, you know, in terms of first 25 minutes will be some multiple choice questions, and then the rest of the time will be, you know, prove or disprove sorts of things. So with that, are there any questions?
Is there a way, so I know we can review our old exams like from the marks that you wrote on it, but is there a way that we can look over the multiple choice question part of the exam?
I think so, but I'm not certain because I don't know what Canvas might look like on your end. But
if I go through quizzes, it's closed just like the rest of the pre-class quizzes, but I tried going through grades like you showed us to do for the other quizzes, but it just tells us the grade portion.
Yeah, so what happened was, because I included the grade that you got on the multiple choice in your exam 2 part, that I moved this to what's called a practice quiz, even though it counted towards you, and I included it in your score. So for the grade book purposes, I had to move that out of the exam category, let me just say. So it is still here. As far as whether you can view it or not, that's a good question. Has anybody else been able to figure that out? I figure you guys would know about the student side.
It just closed on my side.
Okay, well, let me open it back up then. Maybe I can do that. And then you can tell me if that worked. Let's see. So what if I keep it open until here? Lock date cannot be after course end. Okay.
So the question was, we just couldn't see the questions?
I guess. I don't know.
I think there's a way for you to go back and for students to go back and look at their exams. I know I've done it with classes that I've completed in previous semesters, but I don't remember the specifics of how to go about that. Maybe easiest just for you to copy it into a PDF or something and post
That's
it.
not easy to do.
No, okay, never
I
mind
can
then.
just tell you how Canvas works from my end. That would, it sounds like it should be really easy to just say export this to a PDF, but I'm sure you've experienced your own Canvas frustration that sometimes things that should be easy in Canvas wind up being ridiculously difficult.
Yeah, sounds about right.
So Victoria, I just extended the close date until the end, until after the final.
Yeah, I'm checking it right now, and it's working now.
Okay,
Yeah.
let me
So-
do that for the let me do that for the first exam too then.
Yes, perfect. Thank you. Yeah, because I
Yep.
was gonna ask that. Yeah.
Yeah, and so it's possible, since it's a practice quiz, that you'll actually still be able to go in and try and practice answering them anyway. Let's open this one. Whoops. Okay, and let's save that. Okay, so I think you should be able to get into those. And as far as I understand, at least my intention would be that you're still able to get into the old practice quizzes as well, to review those. Because they're actually graded, I think you still should be able to see them in your grade book then. But yeah, if there's anything at all that you're not able to see in Canvas that at one point you were and you would like to see it again, just let me know. Okay, what other questions can I help with?
Can you give us an example of how induction would show up on our exam? Like, as far as, is there going to be a question? Is it just going to be on format of like the way you go about proving, or is it going to be in regards to functions and cardinality and all that stuff?
It could be in both of those things. So certainly there are some proofs in dealing with functions in cardinality that you might need to prove inductively. So for example, one thing that it's one of the proofs in the textbook, but they do a proof like, okay, if A is countably infinite, then A cross A is countably, show that A cross infinite amounts of, or let me write this out since maybe it's hard to, but there's like, so let me just say that there are theorems dealing with cardinality where induction might come up. So for example, if A, so here's that's would be an example of something where you might want to prove this using induction. So these X's are Cartesian products. So if A is countably infinite, why is A cross A finite number of times countably infinite, for example? But I think the general question was, how might induction be on the exam? I certainly could ask you just like induction question that doesn't involve functions that we saw earlier, or you could have a problem that involves induction in the process of countability. I don't think it really would come up much in the functions chapter.
Thank you. I just want to like jog my memory on how induction plays into.
Yeah, and
yeah, that I totally remember this, and this makes sense. So
yeah, and so also let me share my screen. You know, it's not going to be the huge emphasis of this last exam, but so these were the questions on the multiple choice part.
The answers are hidden for the exam. Oh, just kidding, for exam 1.
Okay, yeah, I can change that setting. But like, you know, here's like a sort of multiple choice question that's getting at, without asking you to do a full proof, like, okay, if I wanted to prove this, doing induction, what would be the first step of what would be the inductive hypothesis? What would be the base case, or just something like that? Yeah. So, I mean, what the focus of this course really is proof techniques. So I definitely want to make sure that everybody leaving the class has a good understanding, generally speaking, of these main proof techniques. And the main place where I'm going to see how you could apply them would be in the context of functions and sets and cardinality of sets and that sort of stuff. What else? What other questions? I think there was a question someone sent me this morning. One of the suggested ones. Was that you, Victoria? Sorry to put you on the spot.
Yeah. It was section, I think it was 12.5, number 9. Yeah, okay. 12.5, number 9.
Okay. Yeah, let me just, I'll write it on my iPad for those that might not have the problem in front of you. Okay, and so the problem, so this is 12.5, number 9, which is saying we've got a function f going from R cross n into n cross R. So we're actually flipping some of the Cartesian product, where we're going to take a pair. Say first one is a real number, second one is, I'm using slightly different notation in the book, is a natural number, and this is mapping to that. Where now the first thing is in N and the second thing is in R. So here's our function, and the question is check whether this is injective. It is. So we'll say prove this is bijective, I should say. And we want to give a formula for the inverse of this, or at least give its inverse. This was the problem. Okay.
Yeah.
Okay, so if we want to prove that this is bijective, then we need to prove that it is injective and surjective. So for these, it's almost like an if and only if statement. You've got two things to show. So it's helpful to point out to the reader, when you're doing each of these. So we want to prove that this map is injective. And, there are different ways that we could do this: directly, contrapositively, by contradiction. So was the question, Victoria, on this part of it?
No, my question was on the surjective part.
Okay. So let's come down to that. Yeah, so for surjective, what we're trying to show is that for any pair that's in the codomain. So basically what we're trying to show is that the codomain is equal to the range of the function equals the entire codomain, right? So that every element in the codomain has something which is mapped to it. And so our codomain is n cross r. So let's just say we've got something b, y, which is in n cross r. So b is a natural number, y is a real number. And what we're hoping to show here, so this is really not necessarily part of the proof, but just to put a note, that there exists some element in the domain such that f of this element, which is defined as that is equal to by. And again, in order to do this, you might do a contrapositive. There are different ways that you might want to do this. Sometimes contradiction is a good way to do this. But I think we can do this directly in the sense of if I want to get by as an output of this function, then what can you tell me about what we should set x or a to be? So if I want the first coordinate to equal b, then what should I say about this input over here?
We need to show that f of x maps to b and f of a maps to y.
We need to show that the coordinate xa maps to the coordinate by. So it's an ordered pair here. So I want to show that simultaneously this map is going to take some input where the first thing is in the real numbers and the second thing is in the natural numbers, and it maps it to anything that I can dream up over here. So you've got an equation, right, that we need to solve. If I plug in xa into this function, what we get is 3xa. We get a comma 3xa. And so I want this to equal by. And so what we need to do is solve for x and y, or excuse me, solve for x and a. We want to find out what would be the coordinates that need to go in order to get by out. So who can tell me what a should equal? So if we've got an ordered pair, the only way the ordered pair is equal is if these components equal each other. So this tells me that A should equal B. And now for this one, we actually need to solve for X. So over here, we can just take if I set X equal to Y over 3A, then we're good. And we already found up here that A needs to equal B if we're going to get B as the first coordinate in the output. Kind of did some scratch work over here, and I actually figured out what the input needs to be in order to get that output. So in other words, if I take the point, X is equal to Y over 3B. So let's consider this point, which sits inside of the domain, which is an element in the domain. And now we just say, okay, well, what would happen if I take this input and apply the function f to it, right? Well, the function f says, make that your first coordinate, and then the second coordinate is going to be 3 times the first one times the second one, and that gives us by. Okay, so what we've just shown is that for any element by in the codomain, there exists some element which we actually found exactly in the domain, so that when we plug that into the function, we get by out. Does that help?
Yeah, I was, the only part I was confused was where we got the like the y over 3b part. That was the only part of the question that really like confused me.
Yeah, and I should say that there is a slight issue that no one was concerned about with this. Like, what could go wrong putting that in the denominator?
If B is 0.
It could be 0, right? If B were 0, we would have an issue. This thing would be undefined, but why don't we need to worry about the case with B being 0?
It's because it's in the natural numbers.
That's right. So we know that B is either 1, 2, 3, 4, 5, or 6. So we're not going to have any issues if we divide by B. And then as far as finding the inverse, that's exactly what we did down here. So in this case, we would say that, you know, sorry, that F inverse of XA is equal to A times X over 3A. Or you could use the letters that we used before. I'm sorry, we should take the inverse of, when we take the inverse, right, let me write this out more carefully. So F was mapping from R cross N into N cross R. So that means F inverse should flip that around, right? So it goes from n cross r over to r cross n. And so this was defined as we take an x and we take an a, and it goes to a 3xa. And now this one is going to take a pair that looks like that. So what goes into this function is first a natural number, then a real number. And what's going to come out is the first thing should be a real number. This is the x over 3a, and then the other one was just the a. And again, you know, how could we have found that if we have this relation over here. So when we plug in xa, we got a comma 3xa. And so one way to think about this is to think about, we've got two equations. And we want to solve for a and x. So it's kind of like the same thing that you do if you were trying to find the inverse of, you know, like 3x cubed minus 1, is you just take this equation and you solve for x, right? And that's how you find the inverse. So it's the same thing over here. It's just that we have a system of two equations. So we want to solve those for x and a. And so this immediately tells me this, and this tells me that x is equal to y over 3a. So that's where we got that from, and that's where we got these equations from. Okay, that was the only question I received that I know of, but feel free. Does anybody else have other things they want to ask about? Good to see. Everyone's all ready and prepared. Awesome. No. Let me see. What's coming in here? No, you can't get the answers for the exam. Nice try. I will give you the answer for the homework. That's actually something I wanted to say after tonight. So you'll be able to see solutions for this homework assignment tomorrow. So you can kind of check your own work if it's not graded. I don't know, probably the homeworks won't be graded before the exam. So how's that for a compromise?
Yeah, I guess we can work with that.
What else?
I was looking at the because you know how you opened up exam 1 and 2. So exam number 2 is unlocked and you can see the answers, but exam number 1, it's unlocked and the answers are hidden.
Yeah, I can unhide that. Yeah. Well, I'll certainly fix that, Victoria, in a second. But if there aren't any other questions, you're welcome to stick around if you prefer. If you have something you want to talk about, you know, individually, I'm not going anywhere. If you just want to work on your homework or whatever, relax, that's fine. I just want to say that it was really great working with all of you. You're a really fun class, easy class to work with. I know that this topic is, it's difficult, and That's why it's fun. You know, easy things are boring. So it's tricky, and it's particularly difficult on you during, you know, learning this stuff remotely. But I think you guys have all done a really good job. So I'm proud of all of you. I think you guys have done great. And yeah, I'm sorry we didn't get a chance to all sit around in a classroom together this semester, but for those that are going to be around for the next couple of semesters, hopefully we do have a chance to do that in person. And yeah, so good luck on your exams, everyone. Thanks for a really nice semester. I really enjoyed getting to know you all. And if you do have any other, excuse me, questions, just stick around. And I've got office hours tomorrow as well. But otherwise, good luck getting ready for your finals.